Yeah, here to talk about Native Client. So who are we?
Hi, my name is Blake Bender. I'm the anchor for the Native Client team at Pivotal in Beaverton. I came aboard about 2 years ago, last February. I hired on at Pivotal and relocated to Beaverton from my then home in Austin, Texas. So I am most recently from here. I am thrilled to be back. If you are looking for places to eat or drink or see music, I have lots of opinions, and I'm happy to share them after.
Thanks, Blake. Charlie Black. I'm a product manager for the Native Client. You can call me Geodude, right? Been doing it for a while. So what are we going to talk about today? Definitely going to talk about the Native Client. Give you a little bit of background on it. Some feature, right? So this feature set of it. Some use cases. Talk about a project that Pivotal has called Steel Toe, right? So if you're a .NET developer, this helps you just work in a cloud environment much easier. And I'll talk about some more about that later. And some, Blake's gonna go through some coding examples, and then we have question and answers. And if you have any further questions after that, you could just tap us as you see us in the, walking around the hallways and ask your question then. All right, so before we donated the code to the open source, we did update it to be C++ 11, right? So a little bit of modernization going on there. It was a little bit older code base, so we didn't have smart pointers, so definitely got it nice and pretty for you. The first time that we did a release was in 2018 in December. So this is actually our first appearance at a Geode Summit where we actually have an official release that you can go download. If you want to be a code committer and you're looking through the C++ code, just realize that the server or the client actually was going to intended to be a server at one point, right? We were thinking about making the Geode server being C++. We didn't go down that route. You can see that today. But if you're looking through the code, you might see some concepts. You're like, what is this? And it's kind of like what Dan was talking about. That's in there. Just ignore it. Sorry. Oh, I think I went too far. All right, so some features that we have in here for the Native Client. It's supposed to be on parity with what's in the Java client, right? So, except for it's presented in a C++ format and C#. And we're also going to be thinking about releasing a Node version of this as well. So for those Node.js developers, you're going to be able to use your same Geode installation that you can use with your Java and your C++ and your C# stuff. So some of the features that we have in there, connection pooling, right? So we're not tearing down connections, not restarting them. We can actually keep that in there so that way we can reuse those connections and get a faster throughput. It's all about low latency. Data aware, right? So that thing that Dan was talking about where you can have your client go directly to a server to minimize latency. It's in there. Event-driven architectures, right? You can have durable clients. You can register interest on all your data, specific keys, where predicates. You can do a lot of really cool things with that event-driven architectures. I already said something about durable functions, right? So I can execute my business logic on any of the servers, right? I can actually direct it to a specific server where my data is at, right? Charlie's, it's right there on that server. I direct it there. Or I can run it on all servers to go do some kind of map reduce. Transactions, right? So we can do transactions, totally ACID transactions. So you're really good. One of the things that I'm kind of happy about that the Native Client actually has is we can actually do one thing better than the Java client. We can have more than one access of a distributed system in one client. It's not many use cases for it, but if you wanted to architect it that way, you can set up multiple caches in a given process. So what does our typical deployment architecture look like? Well, it is a client app, right? So if you kind of think about it, it is something that's stood up over here. It's just your application or your service layer. And then you can actually intermix anything, right? So if you have some Java clients, some C#, some C++ clients, they could all be interacting with that same distributed system. So some use cases behind this, rich desktop applications. Probably not so much in vogue now, right? Everybody's thinking about web, but there is a lot of, what do you call it, Visual Studio code out there that is, running your banks out, and not so awesome to be feeling like it, but it's still a valid thing out there. I was one of my applications was a rich desktop app, and it's still out there working, plugging away. And then if you're backing service for a 12-factor app, right? That's a super common use case where you can actually have your .NET applications reaching back, providing enhanced services, and using Geode as your database. And then finally, the enterprise integration patterns, right? If you think about all those different kind of patterns that are out there for, say, doing streaming platforms, right? All those, that event-driven stuff that I was talking about, you can do a lot with Geode on those patterns. So if you think about it in a broader sense of things, wherever you see the database, that little database icon, you can throw Geode in there. And sometimes you can think about it as a message queuing. Would it ever replace, say, a Kafka or a RabbitMQ? No, but at least you can do some of those kind of concepts in your architecture and get away with it. If I was thinking about the full enterprise, maybe I would standardize on Kafka for the enterprise and have us be an actor in there. All right. So steel toe. So what is steel toe? Steel toe allows you to simplify deploying to the cloud, right? So it's a framework out there, just much like Spring. It allows you to just remove some of the boilerplate code that's in there. So if you think about, it does simplify the connection. Well, like if you're deploying to Cloud Foundry and using Pivotal Cloud Cache, right, which is the commercial offering of Geode, steel toe has a connector for that. So what would I have to do from a steel toe perspective, if I wasn't using steel toe? So I would have to go through and I'd have to parse this big JSON document to go figure out where my server's at, right? So I can go off and say, hey, where's my locators? How many are out there? That stuff gets injected by Cloud Foundry. I'd have to parse that. Same thing with username and password. So steel toe just simplifies that. If you are interested in learning more about steel toe, there's a great talk. I believe it's on Wednesday, by Tim Hess. He's the one that actually wrote the connector for us. And you can go get the information out of the horse's mouth, so to speak. Uh-oh, I think I went a little short, Blake.
Great.
Sorry about that.
No worries, no worries. All right, so I want to talk a little bit about what it looks like. The simple code examples, I'll walk you through essentially one of the example apps that we ship with the native client C, just how it's done in practice from .NET environment. Pretty simple, pretty straightforward, but give you an idea for the feel of the thing. Things you need before you start. We are .NET Framework, not .NET Core, so you need a Windows 10 kernel-based operating system. We test internally with Windows 2016 Server. We do development on Windows 10 desktop as well. So pretty much any modern Windows SKU should be fine. Visual Studio, this is actually a typo that made it into the final slide, so I apologize for that. We build with Visual Studio 2017, not 2015, although it should work back a couple of compiler revisions. We build with Community Edition, so you don't need a paid SKU of Visual Studio. The free one works fine if that's what you have. And of course, we work all the way up through Enterprise Edition of Visual Studio as well. You need the Geode Native library. Geode Native's open source project. Our releases are not binary releases, it's source, so you will need to build it yourself from source. We have a pretty extensive building MD on the GitHub repository. It's relatively easy to get built and get up and going. All right, so as you get into the code, there are some objects that you need, and you will collect them along the way. You start with a cache, which you get from a cache factory. Geode programming paradigm makes pretty extensive use of a factory pattern. Once you have a cache, you need to create a pool. Don't necessarily need to hang on to the pool, but you do need to remember the name of the pool. You'll need the pool name to create a region. And you just kind of walk down the line from pool factory to pool to region factory to region, and then you can do puts and gets and some of the actual interesting work of actually storing data in your cache. So here's the first couple of lines. Example of creating a cache, a couple of using statements, not very interesting. New up a cache factory. You see a set here. Set is a call to the cache factory, allows you to toggle any number of switches. There's a long list of these that are supported, and you see them in the documentation. This is just a simple example. Turn off logging because the native client can be quite chatty, and this keeps output to a minimum. During deployment, you would set this log level lower if you're debugging, obviously. Okay, so after you're satisfied with the configuration for your cache on your cache factory, you just call cache factory create. That gives you back a cache. Next thing you do is create a pool. You get a pool factory off of the cache. There's another important API you need to know about here, add locator. You must have a locator or a server in order to create a pool, because the pool is a pool of connections and needs to know server and host and port for your locator or server. So we just add, this is a test for with a local host at the default locator port. And then we create a pool. Pool factory create obviously actually returns an object, but a pool object itself is not particularly interesting to a client application, so we just let that one go. It's out there and created now. We know its name, so we're happy. We can just refer to it later. All right, creating a region is the next thing you do. You get a region factory from the cache. You see this one is a proxy region. We support all of the types of regions that Geode defines. And then we set the pool name on the region factory. And again, the name is important. If you don't set a pool name on the region factory, we'll just throw an exception when you try to create a region, and the exception will say you need a name for your pool. So here we are. We grab a region from the region factory. Note that the region is a generic that takes two types, in this case string, string. Those are your keys and value types. In general, it is not true that your region contains a single type for keys or values. In fact, they can be most any kind of a thing. There's a long list of primitives and a couple of object types, or a couple of interfaces to allow you to serialize, deserialize essentially arbitrary objects. But when you create a region with the native client, you have to pick your types at that point. This would not stop you from going to create another region that maps a different kind of key to a different kind of value and putting and getting values in your region. All right, finally we do some work. So this is the code to put and get a couple of values. Very, very straightforward. Just a username and a full name, a username and a full name. And put value 1, put value 2, get them back, and you see these values, user 1 and user 2. When you get those back out, they definitely should equal Robert Timmons and Sylvia Charles here, in this case, respectively. So again, a value about the keys and values in the region. Values in Geode cache could be a wide variety of things, various numeric types, strings, arrays, two kinds of serializable objects, PDX serializable, data serializable. PDX will be covered in another session at quite a bit more depth later. Rest assured, it's all supported in the native client. Most things that you can do in the Java client, you do in the native client as well. So,
hey Blake, how easy is it to do PDX in .NET?
It is quite simple.
Awesome.
It is a little less simple than an extra slide in my presentation, so we haven't been showing all the setup code, but I assure you it's less than 3 dozen lines of code total. Anyway, so the bottom line with respect to your types in your region is you have to choose the type for your key and your value when you create a region. Again, choose wisely on your types and how you architect the data in your regions. You'll save yourself a lot of heartache in the long run if you have a consistent idea what you want to do up front. All right, here's a little more advanced usage of the native client. This is just issuing a query. The query is to select star from my region custom orders where quantity is greater than 30. And the query again has a type. Type is order. Order is, in this case, a PDX serializable object, a field of which is called quantity. So we can issue queries based on, we can select based on the fields inside the object. Pardon me. So here we get the query back from the query service, execute the query, and it just gives us back a result set in a standard C# collection that we can iterate through and print to the screen. In more advanced usage, there are obviously quite a bit more that you can do with the native client. Again, you can create multiple regions with different types for everything. Custom objects for values or keys. We support function execution, continuous queries, cache listeners, persistence manager if you want to tail off values into your favorite database. Security is a big one. If you are going to push your code to PCC, steel toe, what have you, all of our cloud environments use a basic security called a security manager on the server side, and then you would need to create an object called an auth initialize object in the client, and the native client will ask for credentials. Those get passed over to the server generates a unique ID, and that's how that conversation works. The unique ID gets tacked onto all further messages once you're authenticated. And that's one of, if you're getting into the more advanced uses, one of the first things that you'll probably end up tackling. So that's about all I have for code.
All right.
Thanks a lot.
Thanks for listening. If you want to get into the project, the URL is just Geode Native, right? You could probably Google it instead of just writing that down. I also threw in there a little YouTube video where we actually go off and make an Owen app, right? If you're a .NET developer, that just basically think of it as a Spring Boot, right? An Owen app that just starts up its own process base with its own server. You can go off and watch that to get more familiar with .NET. All right, any questions? All right, I see one. You can say it, I'll repeat it. Okay.
Hi. My first question is, when will Geode support role-based security like RBAC?
So role-based security, all right, it has an ability to do that today, right? You can actually set up roles where you have read and write permissions, but unfortunately we don't provide that implementation to you. There is things out there that have done it off of an LDAP, and you can take your LDAP, say, user, and then map it to a role and read and writes on whatever region that you can do, right? So it's not provided out of the box, it's like an add-on, and you can find an open source version out there. If you Google yet another LDAP Geode, it'll be there and it'll have my name on it.
Oh.
Yeah.
Okay. My another question is, would be a great feature if a compaction can be time triggered if threshold is at certain percentage.
Compaction, yeah. So okay, we'll take that one as a feature request. Just to let people know, compaction just kind of runs when it thinks it is. I always recommend turning it off and saying, hey, go run it when I want you to, so you script something out. But yeah, I get it. Yep.
Thanks.
Mm-hmm. Any other questions? .NET or otherwise?
You do have a couple other chances. We have the panel discussion, and then you have those cards. So.
Yep. All right. Thank you, everybody.
Thanks a lot.